That's okay. 7.6 common logs. All right, this is where I'm not saying this is tough. It's different. It's different. That's the key word. It's different. Okay, so we already know. Hopefully, you have your calculators. We already know this slide, but we haven't actually wrote it down yet. So if you need to, go ahead. A common logarithm. It's a log that has a base of 10. Okay, it's the log that if you look at your calculator at the button next to 7 where it says just log, that's the one it's talking about. Okay, a common log is a log with a base of 10.
Oh, not a log of something.
Right, log base 10 of 5, for example. Okay, this would be like log base 10 of 5, log base 10 of 0.3. But 10 is the most common one we use, so they just got to the point where like, we ain't going to write it no more. And that's what they do. Okay, it's a lot like how you never see the index of 2 on square roots.
No, so if I just write log.
So if you write log, I assume you mean log base 10.
Okay.
Okay, which is what we're going to do today. We're going to use this to do problems that look very, very similar to ones that we've already done. Okay. Let me get this clipped, this there. All right, solve 4 to the x power equals 19. Round to the nearest thousandth, which is how many places? 3.
Baseball has been canceled for tonight, so there will be no game for baseball tonight.
Okay, 4 to the x equals 19. Now, you see what I'm saying about similar problems. Okay? These look a lot like the problems where we used to have 4. We would make 4 2 squared. The right side would be 16 or something to that effect, and we turn it into either 2 or 4. You set your exponents equal, yada, yada, yada. Everybody know what I'm talking about? Okay. The problem now is 19 isn't exactly able to be rewritten as a base of 4. Right? 19 is 1 and 19, and that's it. Okay? Which does us 0 good. So you have to change your approach with a problem like this. Okay? Now, what you're going to do is a little weird. Alright, the first step to a problem like this is you are going to take a log of both sides. You're going to introduce a log into both sides of your equations, just like you would multiply both sides of an equation by a number, divide it, whatever. Same thing. You're introducing this operation of a log to both sides. Okay? Once you do that, the fact that it's a log lets you use one of the properties we learned the other day and bring the exponent from the top down in front. Okay, everybody see that? Just like how last time we moved those numbers up, this time you want to bring it down. Get that exponent, or get that variable out of the exponent. Okay. Now, log of 4, if you have your calculator, log of 4 is 0.60205999913. Alright, that's what log of 4 is. Which is just a what? A decimal number. It's just a number.
Thank you.
So when you look at that problem, you see a whole bunch of letters. What I see is a number times a variable that I'm trying to solve for. So how am I going to get rid of that number if it's being multiplied by x? Divided by it. So divide by log of 4 on both sides. Okay, so the algebra setup to this is this. X equals log of 19 over log of 4, which is about 3/4 of the battle. Okay, get into that. Yeah. Okay, so for your calculator with this, you plug it in, right? Okay, and the only reason I'm actually showing you this screen on this one is to kind of get this point in your head. Log of 19 divided by 4. Or divided by log of 4, sorry. Okay, what's wrong with that? We're at? Good. Okay. Look at this up here. Log of 19 divided by log of 4. You need to close that parenthesis on 19 first. Okay? You can't just do log of 19, because that'll do the log of 19. It'll do 19 divided by log of 4 and then do the log of that. Catch that train? Okay? So what you have to make sure you do is do log of 19 and then close it. That way it does the log of 19 first. Then does the log of 4. Close that. Then hit enter.
That's your answer.
That's your answer.
Mr. Moore.
Okay? Round it. Round it to thousands. Hold on. Okay? So when you round it to thousands, 2.1239, you make it 2.124. Okay? So go ahead through this one just real quick. Give you about a minute and a half or so. 6 to the x equals 42. All right, so take a log. Quiet. Take a log of both sides. Brings the exponent down. Okay, so x log 6.
Can you reduce?
No, I was going to get to that. Log 42. So x equals log 42 over log of 6. Okay. Now, remember what this long division means? It means you're grouping these numerator denominator. Okay? These logs, I don't write them, but they are actually inside parentheses. Whoops, not on the G, on the 6. There we go. So you have to do the log of those numbers first. So no, you cannot just do 42 divided by 6, give you 7, do log of 7, and that's it. It's not the same thing. Okay, so please don't try to get in that habit because it's wrong. All right? But that work there is correct. Okay, so log of 42 divided by log of 6 to give you, what, 2.086, right? Okay. Show me your algebra, show me the setup. Also, one thing, make sure you do it this way. Don't, after you introduce the log, don't turn this log 6 into its decimal number, and don't turn log of 42 into its decimal number for 2 reasons. Number 1, you're going to round it off, and then you're going to make your answer be wrong. Second reason, you're going to write a lot more than what everybody else does, to be honest. Okay? Because we're going to write 3 letters and maybe 2 numbers, and you're going to write 8 numbers. All right? So, everybody good? All right, let's kick it up just a little bit. Oh, don't look ahead. Don't spoil the movie.
I mean, I already did, so it doesn't work.
Oh, it's gonna get worse, Miss Santos. It's gonna get worse.
I start from the math book.
All right, so 8. Here we go. Let's attack this guy. 8 to the z minus 4 equals 6. Shh, quiet. Marcus.
No, I want to try to get it first.
Okay. Oh, you do? Just for time reasons, all right? First step, same thing. Take a log. So log of 8 to z minus 4 equals log of 6. Okay? You take a log of both sides. Still. All right? Step 2, same thing. Bring your exponent down. Except when you bring it down, it comes down in parentheses. Okay, so z minus 4 times the log of 8 equals the log of 6. Same 2 steps. Put in a log, bring down your exponents. All right. Okay, now, just by kind of guessing on your instincts, what do you think the next step's going to be? Why does everybody say that?
Divide by z minus.
That's what we've been doing. That's why.
That's okay. I like it. That's a good logic because that's exactly what you're going to do next. Okay. Now, think about this. Shh, shh, shh. When you bring down that exponent, this exponent. See, I think everybody was going to say distribute because you see this log 8 times this and this, which we're going to do eventually, but not on this problem. Okay. So, see how this is multiplication right here between the parentheses and the log 8. You get rid of multiplication with division, so divide both sides by a log of 8. Those log of 8's canceled. Which gives you z minus 4. Once again, just leave them as logs. Don't try to get the ugly decimal numbers yet. Do that at the end. To give you log base 6 over, or not base 6, sorry, log of 6 over log of 8. Roach.
Do we, the next step, is we at 4?
Yep. Because you're trying to get z by itself. Okay, so add 4. So z equals log of 6 divided by log of 8 plus 4. Show me that setup. Show me what you, just like the equations when you did interest problems. Show me that, so you show me what you're putting in your calculator. In case you screw up putting it in your calculator, I can have a little more mercy on your soul. Drew.
Well, can we divide first before we add forward?
Write it here. Here's what I'm saying. Okay. Write this all the way through. Okay. Get in the hang of it. All right. And here's why. Log of 6 divided by log of 8. Okay. Is 0.8616541669. If you're going to do that, and that's not even the end of it. That keeps going. Okay. I think it's easy to write 6 letters, 2 numbers, and a divide sign. Okay.
You just be at 0.862 if we're doing it to the thousand.
But, okay. Don't, but, you're adding 4 to it, I agree. But, once you get into the harder ones, hey, listen to me. Once you get into the harder ones, if you round early, you're going to be wrong. Okay? Write your logs out, do it all at once, at the end. Okay? DeMarcus.
Just for a moment.
Yes, sir.
I'm over here discovering some things.
Yeah?
Log base 8, 6 is the same thing as log 6 divided by log 8. Like this.
Get the face.
So look.
No.
Get it, all right. Plus 4, or do we wait?
Here's what I do. I do my log of 6 over log of 8. I hit enter, and then I do plus 4.
Okay. That's
Okay? And as you get better with your calculator, you'll start seeing and following its order of operations. On this one here, I'm 99% certain. Let me double check real quick. It doesn't matter. Okay? You can put it in log 6 over log 8 as 1, then plus 4. Or you could put it all in at once. It doesn't matter. It depends on your order of operations and where they fall. Okay? Makes sense? So when you plug this one into your calculator, you get 4.86 and rounds up to 2.
So when you have like the 5y log 3 and y minus 2 log 7, would you?
Will you stop spoiling my party?
I
Oh, you're ahead of everybody in the room. No, gosh, no. No, you guys will hate me for life. And I really don't want
I
that.
have no question about it.
Yeah, if we did what?
If you tried this one without me helping you first, I think everybody would hate me.
Like, I just want to know from.
All right. Now, listen. Your steps from first 2 steps always the same. Introduce the logs to both sides, bring exponents down. So if you guys want to start getting in the habit or understanding to go straight there, so 5y
I've been doing that.
log of 3, next lesson. Okay, equals y minus 2 Log 7. If it's a binomial, it has to be in parentheses. Anything else doesn't, okay? If you did, it's no big deal. So if you want to go straight to that step from the original, that's fine. No big deal. Okay? Now, biggest difference between this problem and the problem prior is what?
There's two exponents.
There's two exponents, and both those exponents have what in them? They're your variable, your y, right. Okay? They have your variables in there. So this is where you cannot divide by log of 7 next.
Oh, really?
You cannot. Because it gets it to the denominator, and you'll see why in a little bit, because it causes us more of a mess. Okay? So your next step is distribute the log. So 5y log 3 equals y log 7 minus 2 times log of 7. Write it like that. Don't write log 7y, because then I think you're taking the parenthesis, the log of the variable, and it won't happen that way, okay? Everybody take that breath. Did you all exhale? Nobody tested, nobody's blue, right? Okay, good. Now, what I want you to do right now is look at this equation and ignore your logs. So let's say we had 5y equals y minus 2. 5y equals y minus 2. What would we do next? Subtract the y. What do we do next up here? What do you think? Subtract the y. What? Y log 7. Subtract y log 7 from both sides. Which gives you 5y log 3. Hang tight. Hang tight. Y log 7. Equals negative 2 log 7. Okay? It gives you 5y log 3 minus y log 7 equals negative 2 log 7. We learn properties that lets us combine logs and split logs. You cannot just subtract them by like terms. Okay? There is no like terms with your logs.
Oh.
Okay?
So you just like brought it over.
Correct.
Okay.
Okay? I got my variables to the same side. Okay? Unlike, the equation earlier when we said, 5y minus y, yeah, cool, 4y. Okay, that's where the similarities end though. Because this does not become, 4y log of negative 4 or whatever you think it might be. You cannot put those together. Okay? Now, the next step to this problem is tricky. Okay? And it's tricky because you're not even thinking of it. You're not even thinking what to do next, because now you move the variable to the same side. Now you have no clue.
Combine like this.
You can't. No like terms to do.
What about the
Nastoff said divide. He's not fully wrong, but he's also not fully right. Okay, let's make sure you're thinking right. Divide by what?
Divide the 5y log 3 minus, or divided by y log 7
Not quite.
on what side?
No. Rochi.
Would you divide by the y log 7, or no, wait,
Nope.
2 log 7?
Nope.
No?
Nope. What do we always want to do when we solve equations? We want to get the variable by itself, right? That's what we said for years. And when we get that variable by itself, how many variables do we have at the end? We have one variable at the end. That's the point, right? Okay? We have 2 right here. So we need to figure out how to turn these 2 variables with a subtraction in between their 2 terms into 1. Tenyas.
Do you divide by 5?
Not quite. No. Starts with an F.
Well,
No.
that's
Yes. Factor what?
5y log 3 and y log 7.
Factor it how? I know, I'm asking the tough questions today, man.
One, I can't answer that.
C!
I mixed up boiling and factoring.
Factor out a y.
Um,
You see how these are 2 separate terms because they're divided by subtraction?
Sure, what do you say?
So there's 2 terms. See how each term has a y in there? So each term has a GCF of y, which leaves you with 5 log 3 minus log 7 equals negative 2 log 7. Okay. Now, does that make sense? You're going to have to do that one on every one of these steps where you have variables on both sides. You'll have another one coming up here in a second.
That's the
No.
answer.
Okay, everybody good?
And then you
Now, you have 5 log 3 minus log 7 in parentheses times a y. That 5 log 3 minus log 7 is just a number, so you can
No, add log,
divide it to both sides. Because these two cancel out. To leave you with y equals all that. All right, now, for your calculator with this one, as you get better, and as you learn how this works, I can see, I can see you being able to figure out how to put the whole thing in. I can't. Don't do it yet. Okay? Do this. Do your denominator first. 5 log 3. Close. Minus log 7. Close. Enter. Okay? Get that. Everybody see that?
Yeah.
Now, open a parenthesis. Do your numerator, so negative 2 log 7. Close the parenthesis on the log. Close the parenthesis on the numerator. Divide. Now, where did that 1.5405 go? When I hit enter on that, where did it go? Where did it get stored at?
Oh,
In second answer. Okay? See where it is down by your negative sign? Bless you. See down here? See how it says A and S? So you hit second negative, and it puts in A and S, which right now it's stored as the last answer, which is that 1.5405 number, the whole thing.
I just usually hit the up arrow and hit enter again.
That's fine too.
Okay.
Okay, however you know to get it there, that's fine. Either way. Okay? One way or the other, you should end up with an answer of negative 1.097. Okay, so negative 1.097. Now, to be quite honest, we're out of time. We're not out of time because we're going to do one more. The best way, if you're getting everything right and the algebra to it all makes sense, but you're getting when you put them in your calculators, you're getting them wrong. The quickest fix, honestly, for it is to come see me. Let me see you do one, and I'll show you where you're going wrong with it. That's honestly the quickest fix. Okay. So if you work on this homework a little tonight and you get the algebra right, but you look in the back of the book and your answer is wrong, don't just assume you have no clue what's going on. You may just miss a parenthesis or something. Okay? And I'll tell you this, the bulk of your points will come from your algebra work of these problems. Okay? Any questions? Everybody good? All right. You guys have one more. Right here. 4 to the y equals 8 to the 2y plus 1. All right, listen up. There's your work. You should end up, if you did it right, with a negative 0.75, which is also known as negative 3/4. Now, two things. Number one, since most of these are going to be decimals, if you did this one and you left it as negative 0.75, I'll be okay with it. I guess. Okay. Second question. What's the shortcut?
the log.
Nope. Nothing with logs. Tennis.
I just straight up took y out and put it in front, and then made it 2. I just took the y out.
I think I know.
No.
How that?
Rochi. Or Reinhardt, whichever one you. Reinhardt, go.
That's fine.
My bad.
Well, couldn't you make like 4, 2 squared, and then the 2 to the, well, 8 to the third?
Exactly.
And just do like 2y equals
Yep.
6y plus.
That's exactly right.
What did you say?
And you can simplify them.
Oh.
This is I took this straight out of your 7.2 notes. 4 is 2 squared. 8 is 2 cubed. You distribute, you equate your exponents. You'll still get negative 3/4 at the end, okay? Now, here's where this gets a little even messier. If you see one like this on your test that I just happened accidentally to let slip through my mind and put into the section of all these problems, and you catch it that you can do your exponent equating thingy,
I don't know what that is.
do it.
That makes no sense to me.
Can
What
we
you
do
tried
it?
to, what you tried to explain and what made the Reinhardt mountain made no sense. Okay, add.
From your original, from the top, this will make sense to everybody because we've already done this.
Okay, I'm doing that. Okay, so if I just did that to be similar. Did I just do that?
Homework is page, not that, there we go. Page 496, 23 through 26, 50 through 52.